Hello and welcome to Learn Data. I'm Nilesh and it's great to have you on this channel. Today we'll learn more about pandas and how we can create visualizations in pandas. Specifically, we'll look at creating different types of plots using a dataset, and these would be line plot, bars, histograms, box plots, scatter plots, Hexbin and pie charts. So let's get into Jupyter notebook and start coding. Here I've already created a new notebook and imported three libraries, NumPy, Pandas and matplotlib.pyplot. Then for data we have this DataFrame. I'll put this DataFrame in the description of this video so you can copy from there. This particular dataset has two columns which are object characters, and then the other columns are numeric. The index is date and date time. So this is completely made up data set. What we are trying to show here is it's a data set for flowers and the availability of flowers in different availability of flowers that were produced in different seasons: summer, winter, fall, spring, on a given date, and the number of orders that could be received on that date. So these are floats, number of orders, so we can think of them as maybe in millions or thousands. So that is the data set we are going to start working with. So very first plot that we can create is a line plot. And it's super easy to create plots in pandas, and these can be really helpful when you want to quickly create plots, do not have time to maybe write a elaborate code using matplotlib. So these pandas plots are built on matplotlib, but it comes with wrapper, so one line of code can create really nice plots. So if we type flowers.plot, and just by typing that we create this particular plot where we have a nicely formatted x-axis, which is time series. Then we have the y-axis, which has the available quantity of the flowers and in thousands maybe, and then we have the legend there. So if we want to change or make changes to this plot, we can always use the commands from matplotlib. So we can add the y label there and say quantity and in thousands, and then we can also go ahead and add the label title and flower availability. That's so that can be there, and then we can also move this particular legend that's in the middle there. So we can set it to the right side, and to do that we can type plt.legend, and this would be bb box to anchor, and here we give a tuple of 1 so that should fix those issues. So these are just formatting things we can add, but if you really need to create a plot, we can just create that plot by writing these two words creates this really nice looking plot. Now moving on, let's create another plot where we are going to use a bar design. So we'll create a bar plot, and for this particular plot I'm going to use just one row of the data frame. Let's use the row 0, and we go from 2 to 6 columns, and again plot kind is equal to bar. So anytime we specify kind, so just to make it look very simple, what we can do is remove this for now, and I'm just going to go ahead and plot this. So when we are plotting histogram, or sorry, a bar plot, all we have to do is specify here kind is equal to bar, and The reason why it's taking so long is because we have a very large data set and we are asking it to print bars for each and every row, which are 1000 rows, and therefore it's taking time. And so what I'm going to do to avoid this kernel crash, I'm going to stop this. So to stop a cell, what you want to do is click on the stop button. It says interrupting kernel and it should have stopped. So this is stopped. So I'm going to delete this and we'll just pick one row and print and plot those columns. So here we go. So these are the availability quantities of flowers that were cultivated in the season of summer, winter, fall and spring on that particular date, which is at index 0, and the date is 2017 January 1. So that was the bar plot. Now moving on, let's create another line plot. So I'll stop typing the section headings just to save time. Flowers, and here we have num underscore. So we'll use this column orders, and we'll take a cumulative sum of that and plot that. So if we do not specify anything inside these parentheses for the plot, by default it will go ahead and plot the line. So when we plot this, we see that we get again nicely formatted x-axis, which is a time series, and we see this line which where we can see fluctuations in the order for the flowers. Now we have seen this, and here what we can do is, if we want to add color to this, we can do that. So if you say color is equal to say red, and then plot this, we get a red line. And if we want to add another plot here, we can do that as well. So let's say if we copy this, paste it here, and just create this new plot with just divide it by 2 and call this blue. So now we have two plots which are on the same canvas or the same layout. Next, let's look at another plot where we are going to create a histogram. But before we do that, what we are going to do is we are going to drop the column num orders. And the reason we are dropping that is because for all other plots we do not need this column. So I'm going to go ahead and drop this. So flowers dot drop. To drop a column by name, what you want to type is df or the name of the data frame dot drop, and then you have num underscore orders, that's the column name, and axis is 1. So now when we look at flowers dot head, we see that that column is no more there. So we have dropped that last column. Now let's go ahead and create a histogram. For histogram, again the command is similar, flowers dot plot, and here we want to specify the kind as hist. And when we plot this, we see that we have easily plotted 4 columns: prod underscore summer, winter, and fall and spring. So these are the 4 histograms. They don't look good right now, and we can change that. So here in this parenthesis, we can add alpha, which is the transparency. We can set it to 0.25. We can also change the bins to, let's say, change it to 30. And now we can see that we have a nice looking histogram. So if we change it to 0.5, okay, this looks good. So with just one line of code, we are able to create histograms for 4 columns in the data frame. And that's the simplicity of using tools within Pandas to create visualizations. We can also create a gallery of subplots for each of these histograms, such that each histogram is in a different subplot. To do that, what we want to do is type plt.figure, and here again flowers dot hist, and color is equal to, let's say, k, and then alpha is equal to 0.5, bins, let's say 30, fig size is equal to, let's go ahead and add a figure size of 10 and 7, just so that the plot is well spaced out. And here we can see that again, with one line, 2 lines of code, we are able to create this plot with 4 subplots for fall, spring, summer, and winter. So we can clearly see how the data is distributed. And so this is like for quick visualizations of a data frame, we can really use this command. Next, let's look at creating bar plots, and we'll use only a couple of columns to create this plot. Flowers, and here flowers.iloc, and we'll use all the 0 to 5 and all columns, and dot plot dot bar, and this way we can create a bar plot. Now we just picked first 5 columns, and the reason is because there are 1000 columns, so we won't be able to see anything in this plot. So this is just to show that we can create a really easily a bar plot, again using the same command df.plot.bar open close parenthesis, and we get this plot where x-axis has the index labels and the y-axis has the quantity, which is for summer, winter, and fall, summer, winter, fall, and spring. And in this particular plot, we can then see that yes, for winter the production of flowers in winter is really low, and it seems to be much higher in case of spring. So at any given date, the availability of flowers that were cultivated in winter is much lower as compared to flowers that were cultivated during the spring season. Now we can also go ahead and change this plot to appear horizontal, and to do that we simply have to put a h in front of the bar, and that flips the plot 90 degrees, and now we have y-axis which has the time, that is the dates, and x-axis has the quantity. So depending upon what type of plot we are trying to show, it can be vertical or horizontal, as we have seen here. And as we saw in the very first plot, this legend can be put outside this by using the bbox to anchor command for legend, so it does not interfere with the visuals that are within this canvas area. Next, let's see how we can create a stacked bar plot, and to create that we just have to specify stacked is equal to true in above command line. So we'll go ahead and copy this, paste it here, and we'll specify stacked is equal to true. This creates a stacked bar plot, and these are helpful to kind of get a whole picture of what's happening. So from these plots we can maybe see that for summer there is a fluctuation in the production levels. As we can see, it goes down daily, so it's not consistent, whereas in case of fall it looks like it's pretty much the same size of the green region, and similar for winter, it looks pretty much the same. And another thing that jumps out is for winter the production is really low as compared to all other seasons. So similar items could be deduced from stacked bar plots. Now moving on, let's look at how we can create box plots. Flowers dot plot dot box, and this is the box plot. So here, as we can see, if you do not know how to read a box plot, this is how you would read it. So in this particular case, these circles that are out here, they could be considered as outliers, but it depends on the data you're looking at. The green line in the middle of this box, that's the median. So 50% of the data lies above and 50% lies below that. And then the lower line of that box is the first quartile, and the upper line of that box is the third quartile. Okay, and the green is the median, that's the center one, and this is the maximum and this is the minimum. So that's how the box plot can be read. So it basically is telling us the entire distribution of the data for this particular column summer. And here, if we want to take a quick look, here we can see that the median is at just around 600. Now if we go back up and look at the histogram, so let's go ahead, summer histogram. Here we can see that the peak for that histogram is roughly around 600. So, and these are the tails that go from 300 to about 900. And if you go back to the histogram, so these also are going from around 300 right over here and up to 900 right over here. So you can imagine that the histogram would be something like this. It's going like that and coming here. So this points to the peak, and that's in the center. Okay, so here this is the simplest way we can create a box plot using pandas, and there are additional changes we can do to this. For example, colors, you can change that, and that can be put in a dictionary. So if we say color is equal to, in a dictionary we can specify boxes, so we can change the color of the boxes. So let's say if we want the color of the boxes to be maybe teal color, and then we can change the color of whiskers. Whiskers are those lines coming out of those boxes, and those let's say we convert them to blue. And then for median, which is the center line, we can change that and maybe make them gray. And finally we have the caps, and for that we can change that to, let's say, red color. So this, and we have to input this color dictionary to the command. So we type flash.plot.box, and color is equal to color, and sim is equal to symbol that we are going to, will use the same symbol that we already have, sorry, flash. And okay, let's see what the error is. Color dictionary contains invalid key whisker. Yes, and that's my mistake. It should be whisker. So everything is plural in there. This is how we can change the appearance of the plot by changing the colors. Okay. Next, let's look at how we can change the orientation of a box plot. So previously we changed the orientation of a bar plot from vertical to horizontal. We can do the same thing with box plot as well. So to do that, we'll type flash.plot.box, and then vertical is equal to false. Okay, and if we just type this, we get a box plot where the boxes are equally spaced, as you can see here. Now if we want them to space out at specific distances, we can do that, and to do that we can specify positions, and positions we need to specify a list. So let's say we want to put the summer at 1, and then all the rest of the 3 at, let's say, positions 6, 7 and 8. So if we do that, then we can separate out the box plots depending upon the need of visualization. We can have a box plot look like this, where the three box plots are separated from the first one. And a use case that I can think of where this could be useful is, let's say if you have healthcare data and or experimental data where this is a control and it's separate than others. So this could be treatments and this could be a control which can be shown as separate from the other box plots. In addition to writing df or flash.plot.box, we can create a box plot another way by simply typing flash.boxplot, and this will also create a box plot, as you can see now. So this is another way. So very simple to create a box plot along with whiskers and everything. So this is a really easy way to quickly look at what's in the data frame, how the data looks like, are there any outliers. So this is really helpful to get that done very quickly. Next, let's look at creating box plot by picking parts of the data frame. So we'll type plt.figure, and now we are going to pick species, which is, so if we can go ahead and look at the data frame again, so we know what we are plotting. So we are going to use this column species to kind of categorize the plots that we are going to do. So flash.boxplot, and here we'll specify by is equal to species and figure size, fixed size, let's say, again we'll start at 10.5 and see how that goes. Okay, when we run this, we see that we now have 4 box plots. So 4 subplots, which each of them have 6 box plots, and the 6 correspond to the species of flowers, so, or the names of flowers from A to rose. So Elysium, Amaranthus, Aster, and then we have these 3 right here. So what we have done here is we have plotted each column separately, and then in each of those column of seasons we have created a box plot for each of the species of the flower that exists. So this is really awesome because we didn't have to write much code. It's just a 1 line of code and we are able to get such an awesome plot. Now what we can do is we can go a step further and create another type with similar looking box plot with new information. So flash.boxplot column is equal to, now let's say we want to use only the column prod summer and then prod winter. So we pick these 2 columns, and then we are going to use the shades. So in here we see that there are 2 shades. I think there are 2. Let's go ahead and check. Flash.shades.unique and okay, there are 2 shades, so we can plot those shades. Sorry, by is equal to shades, and then we are also going to use species. So in the above plot we just have species, here we have 2 items, and then fixed size will again change it to maybe 10.5 and see how that works. So here, okay, so this x-axis we cannot read, so we can go ahead and add rotation is equal to 90, and that should fix that. Okay, so here we can see that now for each of the we have 2 plots, one for summer, one for winter, and in each of these plots we have separation by species as well as shades. So there are two categories that are plotted, and therefore the number of box plots have increased as compared to the previous plot. For example, if you want to find a red color rows, we have the production for that right here, and then we have a blue color rows which has the production distribution that's right here. So this is much detailed information for each specific category of the flower that was cultivated. And this compare also, we have a comparison here where we can clearly see that in winter the production of all types of flowers is much less as compared to summer. And yeah, that's what these two together tell us. And the y-axis for both the plots are comparable, and they have the same y-axis, both of them, so we can directly compare these two plots. Okay, so that was for box plots. There's one last way we can create a box plot that I want to share. Here what we can do is we are going to pick just red. Here we had both blue and red, so we are going to just pick one which is red. So flowers, and here we are going to pick shades which is equal to red, and then we are going to pick only one season. Let's pick prod spring, and we are going to pick the species. Now this is what we are doing up till now, is just filtering the data frame, and then all we are going to type is boxplot, and by is equal to species. Okay, let's see what the error is. Key error, prod underscore spring and species. Okay, prod underscore spring. The reason is when we are trying to pull columns from a data frame, it has to be in two square brackets, and that was the reason. So now when we run this, we get a new box plot which is specifically for flowers that are red in color for and only from spring. So these are the cultivation numbers or production numbers for all the species of flowers that are red in color that were cultivated in the season spring. Okay, so with so many features, we can do a very quick look through the data set that we have and see how what if anything stands out from the data set for further analysis. Now that was for box plots. Let's move on and try to see how we can create area plots. So the method is similar. What we'll type is flowers.plot.area, and when we type this is a simple area plot which is similar to the line plot that we had earlier, except that all the area below the line is now filled with the color, and that's why it's the area plot. Now this particular plot, we can also change the transparency of this plot as we did before, and all those modifications can be done to this plot as well. So for now we'll just change the transparency and see how that looks. In addition to this, we can also create stacked bar plots. So let's try that. Flowers.plot.area, and here we say stacked is equal to, so that was okay. Let's try stacked is equal to true, alpha is equal to 0.5, and let's see how that. Okay, so this, I think the default is stacked, which is similar to what we had above, and this, if we set it to false, now this is not a stacked bar plot. and this is evident from the y-axis. If you look here, the y-axis goes up to 3000 when it is tracked, and that is expected as compared to unstacked bar plot, unstacked plot, where the y-axis goes only up to 100. So this is another way where we can stack or plot the stacked version or unstacked version of the area plot. And similar to the bar plots that we saw earlier, here we can see that for winter the thickness of this orange area is much smaller as compared to all other areas, and that kind of tells that the cultivation of those flowers in that season is pretty much much lower than on the other 3 seasons. Now let's move on to create a few more plots with pandas, and before we do that, I'm going to create new columns in the Flash data frame so that we can use them in the plots. So we'll add a column day, and we'll create it from the index. So in the index we already have the date, so all we have to do is type that plus dot day. So we have flower.index.day, that will create the day from the date, and then flowers, again it should be flowers, and we'll add another column revenue, millions, and which is in np.random random integer. Let's go from 0 to 100, and we need 1000 of these because we have 1000 records in the data frame flowers. So now when we look at flowers.head, we have 2 additional columns right here on the far right. Okay, so let's go on now and create new plots using pandas, and first thing we are going to do is create a scatter plot. So flowers dot plot dot scatter, and we are going to use the prod underscore summer season, and then for revenue we are going to use the revenue underscore million, and this is how the scatter plot looks like, where it automatically has created the labels for x and y axis, and we can see nice scatter plot right here. So again, we can always go ahead and change the appearance of the plot if needed, and make the size of the dots smaller or larger, change transparency, etc. In addition to this is just a plot for this is just one scatter plot. We can also go ahead and add multiple scatter plots, say 2 scatter plots with different colors in the same plot. To do that, what we can do is type, say, x is equal to flash.plot.scatter, and here we are going to use only one species, which is aster. So we can filter the data frame flash, and we can say species is equal to aster. Okay, so that's for aster, and the next we can copy this and then paste it here, and for the second one we are going to specify the flower may rose, and here we need to specify x is equal to x. And now for color, we can specify color is equal to red for this one, and label is equal to rose. Similarly, here we can specify label is equal to aster. Now when we run this, we should get 2 plots. So as we can see, we have 2 plots in one, which is nicely placed, and we can see the production numbers for 2 species of flowers, aster and rose, and accompanying revenue in millions. Now moving on, we can go ahead and create another plot with this data. So let's see, flowers dot plot dot scatter and revenue underscore million, and then prod, and let's use the winter this time. Okay, and let's run this. Okay, let's do flowers, and here we can see that we've plotted the x-axis, which is revenue this time, and we can see the distribution again in a different color, as you can see. Now in this particular plot we can also add the color as days. So c is equal to comma c is equal to day, and now we can see that we were not only able to plot the scatter plot, but now we can also see what was the day when the revenue was x, when the production number was y for a particular season. So this is another way we can create a scatter plot using Pandas library, which is really informative, where we have a graded scale added. So it's more of a 3D plot that we have created here. Moving on, let's create another scatter plot. So flowers dot plot dot scatter, and here we'll specify x is equal to day, y is equal to prod underscore winter, and then we are going to change the size of the circles. So that's another dimension we are adding. So flowers and revenue million. So if the revenue is higher, then the size of those dots would be much larger. Alpha is equal to, let's say, 0.5, and print this. Let's see how that looks. So this is a plot where we have, if the revenue, so the very small dots indicate that the revenue at that particular data point was much lower. So that's likely at day 5 when the production was 325 maybe tons. The revenue generated was much lower as compared to day 4 when the production was maybe around 340 and the revenue was higher as compared to this one. So that's another dimension we can add to the plot, in addition to changing the color as we saw above. Next, in similar to the scatter plots, there's another useful plot which is a Hexbin plot, and this plot is similar. We can plot it in same way, flowers.plot.hexbin, and we need to specify the x value. So say prod underscore summer, winter, spring. Let's put spring, let's put summer, and then y is equal to revenue and million. Now here we need to specify the grid size, so that's the binning. So we'll specify 25, and this is how we can see the Hexbin plot. The way to read this is each hexagon is telling us is, the darker the color, the more data points that particular hexagon had as compared to those that are lighter in color. And we can check that by plotting a scatter plot. So scatter, and we don't need a grid size for that, so I'm going to remove that. Now let's go ahead and put alpha is equal to to 5 and change the maybe size of the circles to 10. 10 is too small, so let's make it 50. Okay, so as you can see, if we look at this dot, which is right here, looks like it's just above 10, so that's this area. So around 600, just before 600, this particular cluster that we can see, that is represented by that dark hexagon in the Hexbin plot. So the Hexbin plots can be used in this way, and they are really helpful to kind of see cluster of data points which we cannot usually see. We do see here, but this makes it more convenient to see those cluster points. Next, let's look at a different type of plot that we have been doing so far, which is a pie chart or a pie plot. And to do that, we need to you create a new data frame based on the data frame that we already have, which is the flowers data frame. We'll create a data frame group underscore flowers, and we are going to group by species. So to do that, we'll type flowers dot group by, and we'll use species, and for this then we are going to sum. So we are going to sum the values for all of these and then reset index, group underscore flowers, okay, dot head. So here we have created a new data frame group flowers, which has a group data, which is the sum of values, and we can go ahead and convert the species column into index. So to do that, we'll write group underscore flowers is equal to group underscore flowers and then dot set underscore index, and here we can give the name species and group underscore flowers. So here now we have converted the column to index, which is the species. Let's now go ahead and create the pie chart. So group underscore flowers, and we are going to use just two columns. One is, let's say, summer, and the second column we want to use the prod underscore winter. And now we'll write plot dot pie, and here subplots is equal to true because we are plotting two figures, and then fig size, let's change this to 10 and 5. Now when we plot this, we can see that we're able to create a pie chart for each of the columns for season summer and season winter for each of the species. And I'm probably asking why those two plots look identical, and that's just a coincidence that the proportion of, let's say, each of the species of flowers produced in these two seasons is the same. That's probably not a real thing, but in this case it has happened. So that's how we can go ahead and create flowers pie chart for flowers dataset. And that was it for this video. I hope in this video you learned how to create visualizations using pandas, especially how we can create line chart, box plots, bar charts, histograms, pie charts, and how to modify the data frames in the process to get these visualizations. In the next video, we'll continue working through the visualizations and look at some other features that Pandas offers to create visualizations. Until then, please like, share, and subscribe. It helps me stay motivated to create more content for you all, and it also tells me if I'm creating the right content that you are learning from. Thank you, and I'll see you all in the next video.